Everybody to Slooh webinar on the night of Jupiter's opposition, where we'll explore the gas giant and learn more about the exciting Europa Clipper mission. So Paul Cox couldn't make it here tonight because the weather had different ideas and he had some outages and no internet. So the weather had other ideas like it sometimes does with the Slooh telescopes. So welcome everybody and thank you for joining us. We've got some wonderful guests tonight, including Michelle Park, who has done a wonderful internship at JPL, who's going to talk to us about the mission. We've got Keith Wasilewski, who's going to be our Slooh expert tonight, talking to us all about Jupiter. And then we have Steve and Sarah, a teacher and student from Hockaday School. So welcome, everyone. Let's get right to the point, and let's welcome Keith Wasilewski, who is a educator and Slooh enthusiast, and he ran Astro Camp last summer, right, Keith? That was like pretty fun stuff. We did that together. And he's also leading the space science camp or space science classes that meet every other week on Tuesdays. So welcome tonight, Keith. Tell us, like, this special treat, Jupiter at opposition. What does this all mean? And what is this picture that we have on the screen that we're all seeing?
Yeah, well, thank you for having me. This is a big event. The opposition, all the planets that are beyond the orbit of the Earth will go into this relationship with the Earth that we call opposition. The animation that you have here appears to be a picture of Jupiter that is after opposition, after the Earth has passed opposition with it. I know that because of the position of the shadow. So this is a big event. Again, once a year, usually the Earth will come into this position with the planet Jupiter. Let's take a look at the graphic that we have lined up. And let's see what we have here. Okay, so it's a planetary arrangement. So I like to think of this as we need a starting point. So the starting point here for us is when Jupiter is at conjunction. So if you look at this position, Earth, Sun, planet Jupiter, Jupiter at conjunction is not visible. All right, it's not visible to us because it's behind the sun. It's a daytime object. Not until the Earth moves in its orbit on this inner path will Jupiter start to become visible as a morning object. We call it the morning apparition of Jupiter. Even though it becomes visible to us in the morning and you can watch it rise just before the sun rises, it usually is not visible on the Slooh telescopes yet. We have to make sure that Jupiter has appeared to move far enough away from the sun that it can be viewed through the Slooh telescopes. The Earth will continue its path around the sun until it enters this first planetary relationship that we call Western Quadrature. Again, this will happen in the morning, just before the sun rises. We've already passed Western Quadrature. That was actually September 12th. From that position of this right angle of the sun, Earth, and Jupiter, we will move into this position that we're at today. So the graphic shows the planetary relationships, but it doesn't really show the order that things happen in. So Western Quadrature will happen first. Opposition is where we are tonight. This is this planetary arrangement of Sun, Earth, and Jupiter. It's a moment in time. Opposition doesn't last for several days. It's like the full moon. The full moon is actually a very fleeting moment. Opposition is kind of the same thing. I don't think we have Slooh telescopes tonight, but that's not an issue because Jupiter will be very good about a month before and a month after opposition, because right here, the Earth is getting closer to and closer to the planet. When we're at opposition, we're just about the closest point of the planet. The closest approach of the Earth to Jupiter was actually yesterday. A day doesn't really make much of a difference here. The Earth is still very close to the planet. Why is opposition such a big deal? Because that's where we get to see all the beautiful planetary detail on Jupiter, or at least as much of it. It's also the time that it's visible in the sky the longest. As the sun sets, Jupiter will arise or appear to arise on that eastern horizon. So two things. We see that planetary detail. We see that lengthy opportunity to use the Slooh telescopes to take images of Jupiter, or you can go outside and see it in person. From opposition, the Earth will continue to move, and then it will enter into this 90-degree relationship with Jupiter again that we call eastern quadrature. Why are these points in these planetary alignments important? Because we see different things. We don't just see planetary detail. Before and after opposition, we also get to see special things, special treats that we don't always see. We'll see this in Mars, and we'll talk about that in a future episode. We're actually going to talk about it on Tuesday when we do the space science class. We see it with Jupiter, and we see it with Saturn. We will talk about some of the special features that we see before and after opposition at the end of the show. But what we're talking about here in this opening segment is just this position that we're at today, and this is it. Sun, Earth, Jupiter at opposition. And to celebrate this wonderful celestial event, we do have a new Slooh quest that's available, Jupiter at opposition for 2024. A wonderful, wonderful event. One of the things, again, to remember is that the Earth moves faster in its orbit around the sun than Jupiter does. So it really is the Earth that's entering into this arrangement of opposition. Jupiter really isn't doing anything. It's the Earth that's moving on this inside track, entering into this alignment, which it will begin leaving by the time the show is over. So that's what we are celebrating today. I'm going to talk again a little bit, like I said, about some of the special observational points that we can look at the end. But Gretchen, I know we have a number of special guests with us here today. So I'm going to turn it over to you and let's find out who we have with us.
Awesome. Thank you, Keith. I love this time of year. I love this Jovian time, right? So first, we're going to talk with Steve Balog, who has been teaching for 34 years. And he has a doctorate in high energy gamma ray particle physics, right? And he actually didn't really start out being a teacher because he kind of lost his like dream job when they defunded the superconducting super collider. But he ended up finding out when he started teaching that that actually was his love and his passion. He absolutely loves it. And I'm so happy to have you here, Steve. And I'd love to hear more about how you do Slooh, how you use Slooh with your students, and then introduce the special guest we have of yours. So, Steve, let us know, like, how do you Slooh?
So I first heard of Slooh. Gosh, I think y'all had just started the Slooh program, the Slooh website, and y'all were advertising at a physics teacher convention, and got to talking to some people there, and they said, "Well, you get free teacher sign up." So I said, "Okay, I'll sign up and see what it's like," and played around with it for off and on for a year or so, and went, "This is a really cool website. This is something I think can hook my kids." Getting them involved and making them feel like they're real astronomers, like get a sense of not only the positives, like, oh, you get some great observations and you learn some cool things, but also the disappointments that sometimes happen when you're a real astronomer. You get everything all set up and, oh, wait, it's a cloudy night and you don't get anything. So I thought that was really cool. And the feature that when they complete each of the quests, they can make their little posters. And so when I went to work for Hockaday, it turns out that they actually have a poster printer that will print 24 by 36-inch posters. And
Oh,
so,
sweet.
yeah, so that was the big thing I was pushing for is I go through in my normal lectures and give them some, underlying stuff about, we hit all the major topics. It's a semester long course, but I assign different little of these projects as each of these quests is like, okay, this is your homework for the next like 3 weeks so you can get your observations, answer the questions, and then I go back over them and see how they did. Well, last year's class was a competitive class. And so I said, if you find any interesting ones that you want to do in addition, that's fine. Go ahead and do that. And so about 3 or 4 of the students, now Hockaday is an all-girls school, so 3 or 4 of the girls got really into how many gravity points can I get? How many quests can I complete? How much astronomy can I learn? And so it was a win-win situation. And that's why Sarah really popped up. Sarah was only brand new to Hockaday that year and uh, came into, she's just this fantastic science student, really great researcher, loves doing research, and is interested in all kinds of different sciences. And so she really took it to heart and became like one of the top Slooh people, Slooh students, not only for our school, but like from the leaderboards, like,
Yeah. Top
worldwide.
gravity point.
Yeah. So, so it was a pretty proud papa moment kind of thing. Like you view as a teacher, like they're all your kids. And so when they do well, you're pretty proud of them. So, yeah. So Sarah this year, is sort of a visiting scholar for my class. We start up astronomy in the spring for us. So we'll be starting here after our Christmas break. And, um, Sarah's already been talking about it. Lots of other kids have been talking about it, and they're all excited about getting involved and doing the quests and getting their posters. Because it's like I told them if there's at the end of the year, that was their big prize. If they could, they find one of their quest posters that they absolutely loved, we'll print it out for them. And since they're seniors, I said that's your first decoration for your dorm room.
Oh
And
man, that's so amazing. I love
so
that.
yeah, so you guys are getting all kinds of advertisement out there. So. All the girls were very excited about it. They spent time talking about which one to get, and then we printed them all out, and um, so they all have their posters that they can take off to college with them.
Oh my gosh. I love hearing how that you guys are using it and how you get this bonus and then you get like your souvenir. I just made that up, right?
That's good.
I am. So that's super cool. So the top gravity winner is here for us today. Can you go ahead and give us a little intro to um, Sarah and the talk she's going to be giving us?
Sure. Sarah's like I said, she was one of my top students. She was as a junior in my AP Physics C class and was one of the top students there as well as taking the astronomy class. She does all kinds of different research. She's into medical research as well as statistics, AI. She's, into astronomy. We had a big event with the eclipse last year in which she was working with another researcher we have a Foucault pendulum, and so she was filming the pendulum to see if there was any kind of like variations when you got into the totality. And but yeah, I'm not, she's in the process of applying to schools, and I told her with all of this, there'll be universities just, fighting each other to get her as one of their, get her as a student. So,
I
yeah,
bet.
yeah.
I bet.
So, Sarah,
Oh
are you
my
there?
Yeah, Sarah, do you want to join us? And I love that project with the pendulum and the eclipse. That's super fascinating. Well,
Yeah.
thanks, Steve. I'm so glad that you came and you joined us and you shared a little bit about how you use Slooh. And I love the idea of your souvenirs. And I think everybody needs to do that. So thank you so much.
Oh, thank you.
So, welcome, Sarah. Great introduction from your teacher, and I'm really, really happy to have you here and to give us this lovely presentation tonight on the Jovian system. So, I am just going to turn it over to you and let you go forward.
Yeah, thank you so much, Dr. Baylog, for that great introduction. I really appreciate it. So I'm Sarah, and today I'm going to be talking about the Jovian system. So if you'll go to the next slide, the Jovian system is the collection of Jupiter, its moons, and its rings. So I'm just going to be telling you a little bit about that. Next slide, please. Thank you. So Jupiter is the largest planet in the solar system. It's a gas giant. It's known for its great red spot, which is a large storm that you can see on the planet. It has a very strong magnetic field, 20,000 times stronger than Earth's. And despite having a 11-year orbital period, it has a very fast rotation, which is just under 10 hours. The next slide, please. So a little bit more in depth on the red spot. It's a massive storm, which has been going on for at least 350 years. It's very large, about 10,000 miles, 1.3 times the diameter of Earth. Its distinct color is not fully understood, but it's believed to be caused by chemicals in Jupiter's atmosphere. It's slowly drifting towards the planet's south pole and shrinking, which you can see in the photo on the right. And its wind speeds can reach about 268 miles per hour, which is very interesting. Next slide, please. Jupiter has many moons. It has around 95 confirmed moons, most notably the Galilean satellites, which consist of Europa, Ganymede, Callisto, and Io. The moons are named after Jupiter's lovers, and it has a variety of moons, not only the Galilean moons, which are the largest, but also has many smaller moons, with some of which have irregular shapes and some have retrograde orbits as well. Next slide, please. So a little bit more about the Galilean satellites. Next slide, please. Io is the most volcanically active body in the solar system with hundreds of active volcanoes. Europa has a smooth, icy surface, and it's possibly has conditions for harboring life. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and has its own magnetic field. And finally, Callisto is heavily cratered with signs of liquid water beneath the surface as well. Some of the other moons, it has irregularly shaped moons, which are typically much smaller than the Galilean moons. These moons are believed to be captured asteroids or comets, and they tend to orbit a little bit further from Jupiter. A lot of these have retrograde orbits, and they have diverse origins. They are diverse in size and characteristics, some being icy, some being rocky, and depending on their just depending on their histories, and have interactions with Jupiter's radiation. As of right now, we know of 80 irregular moons. Next, Jupiter's rings, not as famous as Saturn's rings, but Jupiter does have faint, thin rings composed of small particles. It has 4 main rings and named Halo, Main, Amalthea, and Thebe. They're very dark, unlike in this photo. They're often not visible just because of their composition, and they're often influenced by the moons. Now, some notable missions to Jupiter. First, we have Voyager 1 and 2, which provided the first close-up images of Jupiter and its moons in the 1970s. Next. We have the Galileo mission, which orbited Jupiter from 1995 to 2003, and it also gave us some more information on the planet's moons, including the discovery of the subsurface ocean on Europa and more about the volcanic activity on Io. Next, we have the Juno mission, which has been orbiting since 2016. It's given us some very stunning images of Jupiter, and it's given us data on its composition magnetosphere. Just a fun tidbit about this mission: while Jupiter's many moons are named after the gods' mistresses, Juno, the space probe sent to orbit and monitor Jupiter, is actually named after his wife. So just a little joke that NASA had in relation to this mission. And then the Parker Solar Probe was mainly focused on studying the sun, but it did a flyby of Jupiter in 2021 and provided some information on the planet's environment. these are just some comparisons of the images that you can get with different telescopes. This James Webb Space Telescope you can see on the left provides detailed images of the composition of Jupiter, and then Juno, obviously much more detailed due to its proximity. And then this is a picture that I actually took on Slooh of Jupiter, which is really cool because it's so interesting to see that I actually scheduled this mission, and it feels like I kind of took this picture myself. It's obviously not as detailed as some of the other pictures, but you can still see that it is Jupiter, and you can see kind of like the banding on the image, and it's just really great that I was able to take this image with Slooh. Yeah.
Wow, that was so amazing, Sarah. I really appreciate you sharing that. And what I just found the names fascinating of the moons, and that was pretty funny about
Yeah.
the little NASA joke. Um, Keith, as our Jovian expert tonight, do you have any comments, questions for Sarah about her presentation? I thought it was like so fascinating.
No, I just think it was great. I mean, very thorough. Sarah, welcome to the team on Slooh. We are going to look forward to great things from you in the future.
Thank you.
And I see you being a regular on the show.
Thank you. I appreciate it.
Uh, yeah, it was a really great job. So thank you for being here. And we're going to segue into our next guest, who also spent time at Slooh during school. And she is now an undergrad at Stanford University, and she is studying physics and computer science. And she has a passion for astrophysics research, and she's currently exploring the evolution and death of the earliest galaxies using the James Webb Space Telescope. So she is very enthusiastic about planetary science. She did an internship with JPL. So she's going to speak to us a little bit about the Europa Clipper mission. And in her free time, what free time? Oh my God. She enjoys crocheting and bird watching at local parks. And of course, taking pictures of galaxies with Slooh. So Michelle, welcome today. We're so happy to have you back again to talk to us more about the Europa Clipper. So first of all, how have you been? How are things going with school?
Things have been great. First off, thank you so much for having me. Um, it's been a very busy time of the week with final season coming up, but I always love being part of these Slooh star parties.
Oh, well, we love having you. You're like one of our favorite guests. So
Thank you.
well, let's jump right in. And so, Europa is one of the Galilean satellites, and it's where the Europa Clipper spacecraft is headed. How is the Europa Clipper spacecraft getting to Europa?
Yeah, so that's a great question. So you would expect that Europa Clipper would just head straight to the moon, but that's actually not what's happening here. In fact, what Europa Clipper does instead is a process known as a gravity assist. What that means is that it actually heads towards Mars first, and then slingshots back to Earth, and then back towards Jupiter. So this may seem to take longer, but by carefully adjusting the speed and the course of Europa Clipper, it actually saves a lot of energy and a lot of time. And by doing this slingshot motion, it'll take Europa Clipper about 5.5 years to reach Jupiter and Europa. So you should keep your eye out for April of 2030, which is when Europa Clipper should arrive.
Oh, well, cool. So is Jupiter's opposition, is that important for the launch? Does it have anything to do with it?
So the opposition is not directly correlated with the timing because the timing of the launch is dependent on all of the planetary alignments. So when Europa Clipper does the slingshot, it also depends on Earth's position and Mars's position. But the opposition is important because it is a factor, and it can help reduce some of that travel distance.
All right. Well, that's super cool. It's fascinating to me how it's using this whole planetary alignment to plan its journey, right? So
Mhm.
how will the Europa Clipper orbit in the Jupiter system, like once it gets there, once it arrives?
Yeah, so Europa Clipper isn't going to be orbiting Europa. Rather, it's orbiting Jupiter itself. The reason for that is because as it's orbiting Jupiter, it will briefly fly by Europa, take some really nice pictures and gather some data, and go back to Jupiter. And that's important because one of the greatest challenges we have with the Europa Clipper spacecraft is that Jupiter has one of the strongest magnetic fields in our solar system. It has these like radiation belts with charged particles that could collide with Europa Clipper. So we need to protect its very sensitive instrumentation. By doing these close flybys, Europa Clipper basically dips into these radiation zones and then leaves as fast as possible. So one of the reasons why it's orbiting Jupiter instead of Europa is to protect itself from radiation. And I guess a bonus fun fact is that Europa Clipper actually has this super special radiation protection vault. It's like a box that shields the most sensitive parts within a third of an inch of aluminum zinc alloy. Basically, it's a box that protects the most sensitive equipment from radiation, demonstrating that a lot of Europa Clipper is designed to protect it from Jupiter's immensely powerful and dangerous radiation.
Whoa, that's so fascinating. I love that. So, I mean, it sounds like they had to create a lot of different technology, and there was a lot of work, obviously years and years to make this, to have this even happen. So, remind us again, why are we even doing this? Why is this important?
Yeah, so Europa is actually one of our most promising candidates for life in the solar system. And the reason for that is because it has an ocean underneath its icy surface. So, for context, Europa is smaller than Earth's moon, but scientists believe that it could have about twice as much water as Earth, which is very, very promising. The reason why we know that is because every time we've seen Europa, it has a lot of ridges and cracks, but no craters, which means that some sort of active process is erasing its surface. And scientists believe that the reason for that is due to ocean interactions. That can be because of tectonics or maybe icy volcanoes that are renewing Europa's surface. So the sign of this ocean is actually incredibly promising and exciting for us to hopefully discover some sort of life.
Oh, that's fascinating that the craters are being erased. It sounds like so mysterious. So what's causing all of these conditions? Is it because Jupiter's nearby, or what is happening?
Well, Jupiter is definitely a factor. The reason for that is because if you think about it, Jupiter is immensely massive. It has an incredibly strong gravitational field. And so when Europa orbits around Jupiter, it's basically being stretched and squeezed by its immense gravity. And this causes some internal friction and heating. The official term is called gravitational tidal heating. And apparently, this heating is one of the factors that is keeping that ocean underneath Europa's surface as a liquid, keeping it as liquid water, which is one of the reasons why we're seeing these potential oceanic interactions. The reason why there's a liquid ocean in the first place is because of Jupiter's immense gravitational pull.
Wow, crazy. So why is Europa a good target or possibility for life? Like, what are the factors that all would go into that we'd have to like consider?
Yeah, so for life, it's a little hard to consider because if you think about it, the only example of life in the solar system that we know of so far is Earth.
Right.
But using that, we can sort of piece together what ingredients we might need. And that includes three things: water, chemistry, and energy. So to start, water seems to be a very critical ingredient in Earth, especially liquid water. And the reason for that is because it can create a stable environment for chemical interactions and processes to take place. So that brings us to the second ingredient, which is chemistry. So maybe in class you may have heard of like schnapps, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. It's basically the building blocks of life on Earth. And scientists believe that there could be these kinds of chemical ingredients or processes in Europa, whether that's in the water or potentially the ocean interacting with the seafloor. And then the final ingredient is energy. Now, this is where things get a little crazy. One of the ideas that scientists have right now for life on Europa is something similar to the hydrothermal vents that we've seen on Earth. This is where chemical energy actually comes out of the interior of Europa, creating this hot, mineral rich fluid. So, even though the ocean is in darkness, and even though Europa is incredibly far from the sun, this sort of chemical energy and the heating from Jupiter can basically power life and feed potential organisms or lead to chemical processes to develop bacterial life.
All right. So we can see how there's a connection between these hydrothermal vents and life. And so what role does the Europa Clipper mission play in like exploring all of that possibility?
Yeah, so to begin, there is a really strong correlation with hydrothermal vents, primarily because it's an example we've seen on Earth. So on Europa, you would imagine that there is no light. It's incredibly far from Earth, I mean from the sun, and also the ocean is underneath an icy surface, which means that there should be no light within the ocean. And so we're thinking that maybe if there were life, it will be powered by some sort of chemical energy. So here on Earth, the plants are powered by photosynthesis because the sun gives them energy to sustain itself. Whereas in Europa, we can imagine that there could be some sort of chemosynthesis where the vent water is basically the food for potential bacteria within these hydrothermal vents. And we've seen that here on Earth. And by feeding the bacteria at the bottom of the food chain, that then hopefully can feed more larger parts of the deep sea vent communities. On Earth, we've seen that in tube worms, shrimp, and crabs. But who knows what we might see in Europa, or maybe even potentially another form of life altogether in the ocean. And that's one of the questions that Europa Clipper is aiming to answer.
It's so exciting. It's so fascinating. And, you know, how amazing that you had that ability to be involved with your internship and, you know, being with JPL. And oh my gosh, it's really appreciate you coming on and sharing all this information with us. I'm going to bring Keith back on and see, you know, if you had any questions or comments during while Michelle was sharing this fantastic information. And I'm going to check for any questions.
Yeah,
Uh,
Michelle, thank you. It's always so good to have you on these shows. Gretchen, this is where I think I want to pull up that slide at the end of the cross section. It's what Michelle was talking about, the image of Europa. Yeah, so we have a cross section of Europa here. Michelle, I'm going to just give a lead in here, and if you want to chime in at the end, but certainly I don't want to put you on the spot, but this is what you were talking about. So we have that gravitational pull of Jupiter tugging away at the core of Europa. We can see the core material sort of bubbling up and heating up the ocean floor. It's bubbling to the surface, creating these cracks and fissures in the surface of Europa. The thing that I really like about this is that we see these plumes, which are types of geysers. I don't know if this has been observed, but we certainly saw it on the moon of Saturn and Enceladus. So my guess is that with the Galileo missions, they were expecting to see something like this. I don't know, Michelle, take it away.
Yeah, so we've actually seen plumes in past
Okay.
missions. And
Wow.
one exciting thing is that Europa Clipper is equipped with an instrument specifically dedicated to exploring these plumes, such as looking at what their chemical composition is like, what their temperature is, et cetera, et cetera. So gathering a ton of data that we haven't been able to before. So this is really exciting. Thank you so much for pointing that out.
oh, super cool. Well, that's awesome. I'm glad we had this graphic to share. Yeah.
Yeah, you know, when I saw this and I looked at your notes and I knew what you were going to be talking about, I thought we have to share this. This to me is really exciting because the first time that I ever think that we saw plumes was on Enceladus, which is a moon of Saturn. And that was just it was, you know, on the moon and it was on the rim of the moon and it was just going out and, you know, exploding out into space. It was the coolest thing. And I cannot think of another time that we've seen anything like this. And to think that this is also happening on another moon is just really, really exciting stuff. I didn't. Now, where was this scene that you've seen? Like I said, I haven't seen the plumes.
I believe it may have been with the Galileo spacecraft as well, though I'm not quite sure.
Okay. Anyway, you know, it's just nice that you're here and we're all on the same page. You know, it's so great to have you, to have Sarah, to have Dr. Balog, you know, here to present and just share their love of astronomy and space and some of the exciting things that are happening. This Europa mission is just going to be a great, great thing to look forward to. And so great, Michelle, that you're part of it. I mean, I think that's so cool that we have a Slooh member, part of such an important historic event.
I totally agree. Well, Michelle, thank you again for being here and sharing with us some very fascinating and fantastic information and giving us another bird's eye view into what's happening with the Europa Clipper. So I'm going to take it back to Keith. And Keith, I wanted to ask if there were any fun quests I see that we talked about earlier, but can we talk a little bit more about the quest that was specifically set up for?
Yeah, we are going to take a look at the question. Before we do that, let's take a look at, we've been talking a lot about the Jupiter quest, the opposition quest. I want to bring up, there has been an extension made. So people who are engaging on the quest, usually when we do a quest that is time specific, like the midnight culmination of the Pleiades, it is the night of the event, or when we do a solar eclipse poster or a quest, usually it's for the event. We have made an extension here because we don't have telescopes tonight. And as I said, Jupiter will be really good for the next couple of weeks. So you do have until December 17th to collect your images for the poster. And in fact, I can go on the dashboard here and take over its screen share and show you where to find this.
Yes, please.
Yeah, let's take a look. So if you just go to the Slooh dashboard, beneath the banner for our Journey to Jupiter Europa Clipper tag, there is the opposition of Jupiter quest. Just, start the quest. Takes you there. You go through the introduction. There's some material for you to read. The big thing, of course, is you're going to collect your images. I just plugged in 2 here because we did some experiments earlier. Of course, you can collect up to 41 images. You don't have to collect all 41, but you can choose that many if you want to. Just scroll down, and that will take you to the next page where we are going to analyze Jupiter. Some more information. I want to go to the poster. New features with the poster. I want to edit the poster. On the left-hand side is where you're going to add your images. This was new for me. Quest image. So you just drag and drop your image into the poster. If I only want to use 2, I can change the orientation. I kind of like the way they are here. I can make them bigger. Just drag that out. Let's say I don't have the time to work on the poster, or I just like this really cool layout, which I actually kind of do. You can do that. You can do 40 images, top to bottom, sort of like a grid, and you just finish the poster and finish the quest. So it's a great opportunity. Again, we have an extension. We have a number of days that can do this. This is the standard type of mission that we see on Jupiter. You're scheduling a mission to the planet. But Gretchen, in the slides, we do have other types of missions that we schedule to Jupiter, which are to Jupiter's moons, the Galilean moons. So if we have the page from Galileo's notebook, yeah, the notebook. The page from Galileo's notebook, there it is. So Galileo was the first person that we think to ever turn a telescope into the night sky. And he saw a number of things. Now, there was another gentleman, another astronomer, Simon Marius, who we think might have observed the moons of Jupiter before Galileo did, but he did not publish it in a book. Because of that, Galileo is given credit with the discovery. And you can imagine, it's 1600-ish, and the telescope is a new invention. It's coming from the Netherlands, and he gets his hands on one of these and takes it into his mind to point it at the night sky. Jupiter is not the first thing he looked at. First, he looked at the Pleiades. Instead of seeing 7 stars, he saw 40 to 50 stars. And then he looked at the moon, and he looked at some other objects. And then he did this. He looked at the planet Jupiter and noticed that it had 2 companions alongside of it. I've looked at this diagram, and you can actually pretty much figure out which moon is which just by its behavior food for thought and maybe a fun homework assignment for somebody if they want to take a look at Galileo's observations, see if they can figure out what was happening. The exciting thing about this is we have the Galilean moon missions on Jupiter, on Slooh, that you can also schedule your own. So when you go into the drop-down menu of the Schedule Mission tab, you can choose Galilean moons, and you will be able to see what Galileo saw, an image of Jupiter and its moons, and you can track them over a period of nights and watch the movement of the moons, just like Galileo did here. A lot of fun. Okay. One more slide here. Gretchen, I promised that we would talk about some of the interesting things that we can observe before and after opposition. So this looks a little small to me. You can blow it up at home if you're able to do that. But what we see here is the orbit of the Earth and the orbit of Jupiter. So when we see and observe the moons of Jupiter, a number of things can happen. If the moon is away from the planet, we're going to do this first, it's casting a shadow out in space. All we see is the moon. That's pretty much what we expect. When we look at the alignment here, we see the Earth, we see Jupiter, we see the orbits of the moons around it. The sun is behind us. So the thing to remember is the planets and the moons of planets are always casting shadows out in space. The thing is, what we see on Earth has to do with the relationship of the positioning of the Earth and the planet itself. So before opposition, even though this moon will appear, even though the moon is in front of the planet, it will appear to us here on Earth over in this position here. The shadow cast by the moon will appear to us to be cast to the right of the planet before opposition. And that goes back to that diagram. As the Earth is making that orbit around the sun and coming into position with Jupiter, we're seeing it kind of from the side. The sun is, casting that shadow from the moon into Jupiter directly on, head on, but because of our position, the side that we're on, we're seeing sort of that side view, and that moon will appear to be to the left, and the shadow, when the moon passes in front of the planet, if it does, will be cast to the right of it. At opposition, like we are tonight, the moons don't appear to cast a shadow because the shadow is behind the moon. And as we leave opposition, as the Earth moves out of that arrangement, the moon will appear to be to the right and the shadow will appear to be cast to the left. So it's one of those really, really great things that we get to see on Slooh with the Slooh telescopes when the opportunity arises. One other thing, the moon also can pass behind the planet, which is what we see here with this little black dot. We see the shadow cast by the planet Jupiter out into space, and the moon will spend some time, each of the moons, behind the planet as it makes its orbit around Jupiter. Last slide, this is what we can expect to see on Slooh. When this happens, we see the moon, again, to the left, we see the shadow cast to the right. We know that this is before opposition. So one of the great things to look for on Slooh, if you are ever part of some Jupiter missions and you see this happening, this is usually not scheduled by accident. Someone is taking the time to go through some tables and doing some groundwork and finding out when this is happening in whatever telescope we're looking at, whether it's in the Canary Islands or in Chile or now in Australia. But these are great opportunities for you to catch kind of a rare event. I mean, they happen a lot, but to be able to get them on a clear night with the type of clarity that we have in an image like this, that takes a little bit of luck and a lot of hard work in scheduling a mission like that. So that's what I have to say. Some of the fun things we look forward to before and after opposition, these shadow transits as the moons cross the face of the planet Jupiter.
Awesome. Thanks, Keith. I'm so glad you added in that information about the shadows and how Jupiter opposition, how everything is affected by that. That it's like super cool. And then I was also noticing in this picture, it's kind of a really amazing picture of the Great Red Spot.
Yep, we have the Great Red Spot. There is a quest too, Jovian Day, where you can trace the features of Jupiter, like the Great Red Spot, as it makes its way across the face of Jupiter. Every 9 hours and 55 minutes, we see Jupiter go through one rotation on its axis, and you can trace the movement of features across the face of Jupiter, very much like the Sun quest that does the same thing. So that's kind of a fun thing. Great image of the red spot. And a shadow transit all in the same image. That's a good one. That's a keeper.
I agree. I love it. Well, I think that brings us to the end of our show, unless there's anything else that you wanted to add about Jupiter that you think we left out that people should know.
Yeah, I think just remember the quest. You want to do the Jupiter opposition quest. That again is a moment's quest. So even though opposition is tonight, you have a couple days, almost 2 weeks or more, well, 2 weeks to work on the quest, collect your images, to make your poster. I think it's great that Dr. Balog has access to a printer. I can't imagine how these look. For most of us, we just get to see the beauty of the poster through an electron medium. I can't imagine seeing it hanging on the dorm room of one of the students who've actually printed it out. Wow, that's great stuff.
Have you ever printed out one of your posters?
No, but I know there are some members who have. They say they turn out great. No, I've never taken one to a printer. Maybe
Yeah, well,
that might be something I have to look into doing at some point in the future.
yeah, definitely. I think that Dr. Balog has got us onto something. Like I said, we'll have new souvenirs, right? I want to thank everybody who joined us tonight for this lovely star party. Dr. Balog, for bringing in your passion and always super excitement for Slooh and sharing it with the students, and Sarah for your lovely presentation. It's fascinating learning, diving in more to Jupiter and the moons and the names, and it was really lovely to have you here. And Michelle Park, thank you as well for joining us once again and sharing great information with us. So, I think we might have a question in the chat. Well done. It's worth Carol Botha, one of our longtime Slooh members, got up at 3 a.m. to join us tonight. That's dedication. So thank you, Carol. It was great to have us here, and I'm glad everybody learned a lot. And that is it. Have a great night.